Hey guys, Mr. Carey here. We're just going to be revisiting what we did yesterday. Today we will be again revisiting arrays, and we're going to be learning a little bit more about the commutative property, okay? So as we said yesterday, the arrays, what an array is a picture of multiplication, okay? It's a picture of equal groups in rows going across and columns going down. And it represents a multiplication or a division problem. For now, we're just going to focus on the multiplication, okay? So how we do these, we're always going to go down, then across. Down, then across, okay? So I count how many are down. 1, 2, 3, 4, 5. And then I just count how many are across. 1, 2, 3. So we call this a 5 by 3 or 5 times 3. So the down number comes first. That's how many groups. That's how many in each group, okay? So you can see these are groups of 3. So I have 5 groups of 3. So then what I would do is I would just count by 3s. 3, 6, 9, 12, 15. 5 by 3 is 15, okay? So check this one out. I got how many down? I got 1, 2. Then I got 1, 2, 3, 4, 5, 6, 7, 8, 2 by 7, or 2 times 7, or 2 groups of 7. See them? 7 and 7. So this time I would just count by 7s 2 times. 7, 14. Okay. Now, the whole point of doing this multiplication, instead of just counting, say you want to count by ones, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Yeah, you'll still get the same answer, right? But what if I have a big one like this? Do I really want to be counting by ones? Not really. If it's equal groups, you skip count, it'll save you a lot of time. What do you have to do huge ones, like when you get to 5th grade, you have to do like 87 times 28. Are you really going to draw 87 groups of 28 and then count by ones? It would take you all day, and most likely you'd probably make a mistake. Speaking of mistakes, I made a mistake intentionally. Now check this out. I made 1, 2, 3, 4 groups of 1, 2, 3, 4, 5, right? Or wrong? Is there anything wrong with that picture? Do you see how it's not equal groups? Do you see how right down here I'm missing one? So this actually wouldn't be an array, and it wouldn't be multiplication at all, and you would just have to count it. But say it was equal groups, right? And I would just want to count those. I would count down 1, 2, 3, 4 by 1, 2, 3, 4, 5, or 4 times 5, or 4 groups of 5. And so this time, I'm just always counting by how many across. I'm just counting by 5s. 5, 10, 15, 20. 4 times 5, or 4 groups of 5, is 20, okay? Now check this out over here. So, now I got a big one. Uh-oh. Yeah, no big deal. Easy, actually. So let's just count. How many down? 1, 2, 3, 4, 5, 6, 7, 8. By 1, 2, 3, 4, 5. I have an 8 by 5, or 8 groups of 5. Do you see the groups of 5? They're going this way. So I would just be counting by 5s 8 times. And you might say, Mr. Carey, I can't do big ones like that yet. Yes, you can. You can count by 5s 8 times. Just use your fingers. Ready? 5, 10, 15, 20, 25, 30, 35, 40. 8 times 5 is 40. Okay? Now next we're going to talk about something called the commutative property. So the commutative property is, you learned a little bit about properties last year with adding. It's a property of multiplication, so it means the order doesn't matter. So for example, if I had 3 times 2, and I counted by 2s, 2, 4, 6, I have 6, right? Or if I had a 2 by 3, and I counted by 3s, 3, 6, my answer will be the same. because nothing really changed. It's just what I'm counting by. This time I counted by 2s 3 times, 2, 4, 6. This time I counted by 3s 2 times, 3, 6. So nothing really changed. If you go by 3 or if you go by 2, your answer will still be the same, okay? So, check it out. So say I have here, right, a 2 by 3, you can see the 6. Or if I turned it like this, well, I didn't change anything. I still have 6. I just changed the way I'm looking at it. This way I'm counting by 3s. This way I'm counting by 2s. But either way, it is the same thing. There's still 6, okay? So the commutative property, it's like the order just doesn't matter. So if I have 3 times 2, it would be the same as 2 times 3. In 2nd grade, you might have called these turnaround facts or a fact family or something like that. So I have 5 times 6 would be the same as the 6 times, well, 5. It's just the other number, just turn it around. 7 times 8 would be the same as, turn it around, 8 times 7. Or you can use it for like big facts. Say like you're doing 9 times 8. You say, well, if I told you 9 times 8 is 72, then you also know that 8 times 9 is 72. Answer will be the same. And so what's going to happen as we're learning multiplication this year is you're going to find out which ones you like. Maybe you like skip counting by 8s more than 7s. So if you have 7 times 8, you can go by 8 7 times or 7 8 times. Or maybe you're doing 6 times 5. Well, I always go by 5 because I love counting by 5s. It's easy. I'd rather count by 5s than 6s any day of the week. Or maybe you're doing like 12 times 2. You'd rather count by 12s 2 times than 12 times because it'll take you longer. So the commutative property helps make things easier and we get to pick which number we want to count by, which is pretty cool. So today is just mostly arrays, a little commutative property. I think you guys got it and I will see you later.